students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today is Sunday and today we are going to solve the mock test 16 answers. Okay, the chapter was organic chemistry. So whatever topics we have covered up to purification of compounds in this particular week, those questions are given here. Okay, so now let us see the first question. So the first question is IUPAC name of the following compound. So what we can do, first step is to do proper numbering, right? 1, 2, 3 and 4. So you will get here methyl group and here methyl group. So what I will get 2,3-dimethyl but2-ene. Okay, so we will get here you can see 2,3-dimethyl but2-ene. Option number A is the correct answer here. Okay, next question, the IUPAC name of the given compound. So here you have acid group and here you have ketone group. Now when ketone group is present as a substituent, we have to name it as oxo. Okay, when ketone group is present as a substituent. Now here COH group is present, it is a main functional group, so the numbering should start from this side. Okay, so if I number it, what I'll get? 1, 2, 3, 4 and 5. Okay, so now if I see on 4th carbon, you have 4-oxo pentane 1-oic acid. Okay, so that is option number B. Next, question number 3. Which of the following is not a pair of functional isomers? So functional isomers means there should be difference in functional group. Here you can see OH and OCH3. These are alcohol and ether. So this is a functional group. Here you have NO2 and here you have NH2CH2 COOH. Okay. Let us see the other examples also. Here you have acid group and here you have ester group. Okay, here you have okay, this one. Now you can see this one. This is also functional group. Here you have nitro group and here you have acid group. But here if you see the structure, it is like this: CH3 CH2 OCH2 CH3, right? And here you have CH3 CH2 CH2O CH3. Okay, so this is 2 and 2 and this is 3 and 1, right? So this is also ether functional group, this is also ether functional group. So these are not functional isomers, rather these are metamers, where you have different number of groups along the side of the oxygen. So correct answer is option number D. Now next question, the number of pi bonds and sigma bonds present in naphthalene are respectively. Okay, so now if you see the structure of naphthalene, okay, so we can draw the naphthalene structure like this. Okay, so I think this is the structure of naphthalene. Okay, we will draw it. Okay, so now you have to calculate the number of pi bonds and the number of sigma bonds, right? So okay, I think I have drawn the structure here wrong. The structure is like this. Yeah, okay, so now I can draw like this. Okay, just mention all the hydrogens first so that we do not forget the hydrogen while calculating the sigma bonds. So easily I can find that there are 5 5 pi bonds, so I can eliminate this option. Okay, now you have to calculate the sigma bonds. So how many sigma bonds we have? So 1, okay, this is 1, 2, 3, 4 and 5 and 6. 6 here, 7, 8, 9, 10, 11 here. Okay, next we have 12, 13, 14, 15, 16, 17, 18, 19. So 19 and 5, so option number B is the correct answer here. Next, resonance effect is not observed in. So for resonance, what we want? We want conjugation, right? So in which of the following we have conjugation, you can see. So you can see that there is conjugation here. Okay, there is conjugation here also. There is lone pair here, so here also conjugation is there, but here you cannot find any conjugation. Option number D is the correct answer here. Next, identify the correct statement in the following: dimethyl ether and ethanol are chain isomers. Okay, next you have to find the correct statement. This is incorrect because they are functional isomers. Ethanoic acid and methyl methanoate are position isomers. No, these are also functional isomers. N-butane and isobutane are functional isomers. No, they are also chain isomers. Pentane 1-OL and propane 1-OL and propane 2-OL are position isomers. Yes, this is correct because the position of OH group is different in both the compounds. Next, question number 7, in which of the following homolytic bond fission takes place? Okay, so that is in the free radical process, free radical chlorination of methane, option number A. Okay, so in the first step what happens, the chlorine molecules breaks to give you Cl and Cl. Okay, next, miscible mixture of C6H6 and CHCl3 can be separated by. So these are two solvents having very significant difference in their boiling point, and they can be separated by distillation. Next, which of the following compounds possess the CH bond with the lowest bond dissociation energy? Okay, so now if I see the structure benzene, okay, so this is benzene, 2,2-dimethyl propane, so you have like this. Okay, next we have toluene, okay, next we have N-pentane. Okay, so now they are talking about the CH bond. Okay, now you see if this CH bond will break, okay, the carbocation formed here will be very stable because of resonance, right? So this CH bond can break easily, so that is why it has low bond dissociation enthalpy. So the answer will be toluene. Okay, next, question number 10, the IUPAC name of the compound. Okay, so here you have the IUPAC name, you can find out. We can start numbering from 1, 2. So on 1 position we have bromine, so I can have this option and this option, and I can eliminate this option. Next, 1, 2, 3, 4, right? 1 bromo and but 2 ENE, that is option number A. Next, question number 11, carbocation as an intermediate is likely to be formed in the reaction. Okay, so in this one happens, carbocation as an intermediate is likely to be formed in the reaction. So if you see propene reaction is there, in this what happens, free radical is formed. Okay, in acetone and HCN there is no carbocation formation. Hexane with A anhydrous, this one we get carbocation, so option number D is the correct answer here. Okay, so if you see here, one second, this is hexane, this is hexene. Okay, sorry. Okay, so we have this one 1, 2, 3, 4, 5, 6 with anhydrous AlCl3 and HCl. Okay, so this is like this. You get a carbocation here, and this one of the carbon shifts from here to here. Okay, so that is the mechanism. Next, question number 12, the structures of these are given represent what? So if you see CH3, CH, NH2 is in the second carbon here. Okay, and here NH3 is on the third carbon, right? So these are your position isomers, option number B. Next we have, which of the following is an isomer of ethanol? So ethanol isomer is, we have 2 carbons, right? So that is dimethyl ether, option number D. Next you have the order of decreasing stability of the following carboanions. So carboanion stability will decrease if there are more plus I groups. So this one will have least stability, this one will have highest stability because it is with resonance. So 4 will be the first and 1 will be the least, right? So there is only one option like that, so option number B here. Next, which type of intermediate A is formed during the reaction? Okay, so in this case what happens, heat is given, right? So that is why free radical mechanism, option number C. Next, which of the following is the incorrect order of stability of carbocations? Okay, so stability of carbocation, here you can see 3 pH groups are there, so it will be more stable due to resonance. Okay, then here if you see, yeah, here this tertiary one will be more stable, right? But it is given secondary one is more stable, so this is the incorrect one, option number B here. Next, the structure shows, so you can see here both the groups attached to this carbon, to the I can say restricted center, both the groups attached is same, so there will be no geometrical isomerism, but this carbon is chiral, so it can show optical isomerism, so option number B. Okay. Next, a miscible mixture of C6H6 and CHCl3 can be separated by, we have just solved this question, so it was 19, question number 19 is again from distillation. Now CH3 whole 3 4 N plus is neither an electrophile nor a nucleophile because does not have electron pair for donation as well as cannot attract electron pair, neither has electron pair available for donation nor can accommodate the electron since all the cells of the nitrogen are fully occupied, right. So nitrogen has all the like you can see, if nitrogen valency is sp3 or nitrogen, it is like 1s2, 2s2, 2p3, right. So now if I have like this 2s2 and I have 2p3, right. So now nitrogen has formed bond with 3 CH3 groups, right. So this is CH3, this is CH3 and this is CH3, right, and it has also formed with another CH3. So there is no vacant orbital, so that is the option number B here. Next, what is the number of primary, secondary and tertiary quaternary carbon atoms present in the given structure? So the first one is primary, 1, 2, 3, 4, 5. So we have primary 5 carbons, option number B. Directly you can do, no need to check. If you want to see also tertiary, you can find 1, okay. Secondary you can find 1, 2 and secondary we can find 2, tertiary we can find 1 and quaternary we can find 1, okay. Next question, minus I effect should be electron negative elements, option number C, okay. Next, the decreasing order of reactivity towards electrophilic substitution of the following compound is, okay. So these are the compounds, okay, and it wants to react with the electrophile. Now if this one wants to react with the electrophile, this compound should behave as a nucleophile, right. So that means it should be having electron rich group. Now if you see here, this one is donating electron, this is withdrawing electron, this is only donating electron, plus I effect, right. So here the ring is more electron rich, so it can react better with E plus or electrophile. So fourth one will have maximum, so we have these two options, I can eliminate these two. Now these two are electron withdrawing groups, so this will be least, so after 4 1 will come, so again we have 1, okay. Now if you see here also it is withdrawing, here also it is withdrawing, but in the case of this one, withdraw is from minus I effect and here it is from minus R effect, right, and we know that minus R is more powerful, means here withdrawal will be more and this ring will be less electron rich to react with this one, so 3 will be the minimum one. So option number C is the correct answer, okay. Next, identify the correct IUPAC name of the compound. So you have 1, 2, 3, 4, 5. So that is your butane nitrile, okay. So when you say nitrile, you are showing 1 carbon and this one is butane, okay, option number B, okay. Next, malic acid and fumaric acid are your optical isomers, okay. They are having same structure but their rotation is different, so it is optical isomer. Next, the IUPAC name of tert butyl chloride. So if you see tert butyl chloride, okay, so it is 2-chloro-2-methyl propane, option number A. Next, arrange the following in the increasing order of the stability. So here you can see this is 1 carbocation, this is 1 carbocation, this is 1 carbocation, this is 1 carbocation and this is a carbocation, okay. So you can see here there is no group, so this one will be least stable, right. So I can eliminate these two options. Now here you see there is only 1 group, so after 5 4 will come, so here also there, 3 also there, out of 2 and 1 only you need to decide, 2 and 1, okay. So if I see 2 structure is like this, okay, this is structure 2 and structure 1 if I draw, it is CH2 CH3, okay. So now you see here there are 9 alpha hydrogens, okay. 9 alpha hydrogen means there will be 9 groups, okay, which there will be 9 hydrogens which can which will stabilize this one, right, okay. Next, here you can see there are 3 plus 3 6 7 8 hydrogens, okay. So 8 hydrogens will be able to stabilize less than compared to 9 hydrogen. You have to see the hyperconjugation effect. So which is more stable? Obviously second one is more stable, right. So after I will get this one, I will get second, so option number D, okay. Next is question number 28. What is the hybridization state of benzyl carbonium ion? Okay, so if you see the hybridization state here, you can see how many sigma bonds it has. 1, 2, 3 sigma, right? So 3 sigma means sp2 hybridization, option number A. Okay. Next, the number of sigma and pi bonds in pent 2YENE. Okay, so you have like this. So we have 8, 1 second, okay, sorry, it is pent 2YNE. I draw the wrong structure. Let me draw it again. Pent 2YNE. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 sigma bonds and 2 pi bonds. So option number A. Okay. Next we have question number 30. Identify the electrophile in the following. So here you see lone pair is there, so it is a nucleophile. Here lone pair is there, here negative charge is there. AlCl3 is electron deficient, so that is a one which is electron deficient and we call it as an electrophile. Okay. Next, okay, so students, I just want to announce you regarding the PU2 success blueprint test series. So as you all know, Christmas offer is going on, so you can use the coupon code to avail flat 100 rupees off, and you can use the coupon AISH100. Okay, so you will get rupees 100 off in this, and you can avail the test at 499 rupees. Okay, so you will be getting 12 mock test papers, video solutions, doubt clarification, as well as one shot revision videos. So if you want to avail this, please go to the description section, click on the link for test series and buy the test series as soon as possible, because this offer is valid only till 28th of November. Okay, clear? Fine. Okay, that's all students. So thank you so much and see you soon in the next class.